I kind of never remember exactly which week it is. So then I'm like, is it the end of this week or next week or what day is today?
Yeah, that sounds right.
Is that aging?
This is going to be a great podcast. Damn.
Just know that that this is being recorded and I'll sue your ass.
Rachel,
It won't be for libel, though. That's for
Can
sure.
you please cut that in because it was just too good. It was just too good. All right, let's go.
I really hope we're recording right now.
I mean, I already started the episode.
All right. Well, okay. We're just going to pick back up from where Robin's had. So welcome back to Roid Rage. This is episode 26.
He just said back.
You know, I mean,
Is that half a year? That's half a year of Roid Rage.
what is time? Sure.
I think technically it's 26.
52 divided by 2
Yeah,
is
26.
26.
Yeah.
Didn't you just say episode 26?
I did say 26. That's
half a year.
Correct. Yeah.
All right, half a year.
See how good we are at math at
Half
AstroForge?
a year.
If we
Half a
make
year
it through
podcast.
this one.
Yeah, fair enough.
Don't count your chickens,
that's
baby.
ominous. All right. Well, today we are going to talk about orbits. To have some actual somebody who knows anything about orbits, we have James, who's joining us as one of our flight dynamics engineers. So, James, before we get started, who are you? Why do you care about orbits? And tell us more about you. Yeah.
Yeah. Hey, Al. I'm James. I'm a flight dynamics engineer here at AstroForge and have a master's and undergrad degree in aerospace engineering with a focus in GNC or guidance, navigation, and control for spacecraft. And the reason that I did any of that was because Star Trek is really fucking cool, and I wanted
Star
to make
Trek?
it reality.
Which
Yeah.
one? Which one?
This is going to be embarrassing. Enterprise is what I
Is
watched.
that the one with the
growing
French dude?
up.
John Picard?
No, it's not the one with the French dude.
Okay.
No, this is Captain Archer.
Who's the one with the guy from Dune?
No
The
idea.
original Dune.
What was the topic of this
You watched
episode?
We're going to get to orbits. Don't worry. He's telling us why he likes orbits. He watched
Star Trek.
Star Trek.
I'm trying to relate what Star
Star
Trek is
Trek
what.
doesn't orbit.
Well, not well. But in general, I like the idea of exploring, places that are far away from us, not just like, going to the moon, basic shit like that.
All right, we're going to need another theme song.
Okay, cool. So you found us because you're like, these crazy guys need to know how orbits work.
How did you
right?
find out about us?
I think it was one of the
hell
blog
were you
posts y'all
thinking?
did. It got linked, and then I was like looking for new, interesting stuff to do, and it seemed like a great opportunity. Yeah.
Okay.
I knew they were worth it.
Yeah.
All right.
Well, I mean, he hasn't been here that long.
Yeah, TBD actually.
Yeah.
Let me take a step back. Yeah, we'll see. Okay, fair enough.
All right, let's get into it. So I want to start off with like the basics. Like, what is orbital design and how does that work in a flat Earth theory?
So in the flat Earth theory, typically it's just you throw it up and then it comes back down. As I think by yeah.
Okay, great.
When we generalize to a more round Earth
Yeah.
theory, typically it involves trying to determine what the thrust is that you're going to use to get to a destination. So you are trying to figure out what burns you're going to have at what times when in orbit to be able to reach some other location at a different time in the future. And typically we try and optimize that value.
That's like the simplest explanation I've ever got for all these little lines we see.
Yeah, I'm actually sort of shocked at the simplicity of that. I was expecting to like barf all over that and come back with a question. I'm a little stumped right now.
It's just optimizing thrust. That's it. Although ours is kind of a pain in the ass because we don't have a rocket engine. We have a little Hall effect thruster.
We don't technically burn.
Yeah, we technically throw ions.
Is there no burning involved? I guess technically not. No.
No.
Yeah,
Let me ask the propulsion team. No.
Okay.
No burning.
Why we don't have a propulsion team because you looked out no one.
So how hard is it to
check
how
my
hard
LinkedIn,
is this,
buddy?
How hard is this problem as opposed to an instantaneous thrust trajectory? We have something like a rocket engine, right? I mean, the only other deep space mission that I'm aware of that's gone out into the cosmos without instantaneous thrust is Psyche with its Hall
Yeah.
effect thrusters. So how difficult is this?
So the most complicated trajectories I've seen of all time have been all with the high thrust version. So like stuff like Cassini and things like those are, and then the people who made that went on to teach a lot of the people on our team. And then what they were teaching us is how to do low thrust because it's the more interesting problem.
Why is Cassini complicated?
Because they did multiple flybys of multiple bodies, like I think like, you know, Mars, Venus, Earth again, like it went around the whole cosmos. And they had to come up with a series of burns that were very far apart. My understanding is that it took a lot of computers a lot of time to figure that one out. For the low thrust version, basically you don't get to like just choose like 2 or 3 points. Instead, you have to choose thousands of points that you're trying to optimize. And so it just is multiple orders of magnitude harder. And it's also in general considered to be less efficient. So you don't know exactly how to do it properly. Like you don't, you get a value that is like the best possible value from doing the high thrust version. And then you work backwards and try to create smaller points that you're going to optimize through and get a
Less efficient in what terms, as far as fuel cost or time cost?
all of the above, because in a high thrust version you have a single burn point. So in the low thrust version, the first order is you take that single burn point and turn it into a burn segment that you're trying to get. Like, let's say you were to burn 1 meter per second with a high thrust. Well, that 1 meter per second would require half a day perhaps with a low thrust. And so you're going to take a single point and make it half a day. And then each individual point you're burning at is not as efficient as burning at the most efficient point once.
I'm so confused.
Yeah.
I'm fucking lost.
Yeah.
That didn't take long.
Yeah, you lost me right away. I'm gonna go back to doing like fundraising or something.
That is actually a first, I think. Like, congrats. We're
Well
half
done.
a year into it, and you're the first person to just be like, Cosmat say, like, I have no idea. Yeah, well done.
Wait, so like in normal easy orbital mechanics, you do stuff like Holman transfers.
Yeah.
So clearly in continuous burn, low thrust profiles, there must be somebody else important who has a methodology.
I think
Named
the problem
after
is
them.
that we had so many individual contributors that we don't have a lot of great, names for the transfers.
Dude, you just
Yeah.
lost the opportunity to name that shit after yourself. That's how
It's
all
the
great
Bell
science is
transfer.
partially stolen.
Yeah.
I feel like I just lobbed it. You know?
You
Yeah.
did. You set them up perfectly.
Yeah.
It's all right. We actually, what we can do is we can cut that out because we learned that Rachel can do editing, and we can just roll this back.
Wait a minute. We don't have to just put out on the air this crap that we spew.
Yeah. Yeah.
Oh, then go back, Rachel, and call it the gullet transfer. Done.
All right. So you got here. You're working on Vestry. Where do you start with designing an orbit? Like, what factors do you take into account? What teams you work with? Like,
Dude,
How
he
do you-
just told you he uses the high thrust profile and then breaks it down
And then
into
he adds
segments.
dots. He adds points, and then
It's
there's
orders
dots.
of magnitude more difficult. Okay.
How do you get us to a fucking asteroid in
Yeah.
English?
No sé. So it's ultimately we have to figure out what asteroids we care about first. So we look at asteroids
Metallic,
that are
platinum rich.
those are great.
Yeah.
So we that's like the third pass.
Okay,
So
sorry.
the first
doesn't
pass.
care about your types.
Yeah. I don't care about the income. I care about which ones we can even reach, and then we go to
Oh, all right. Yeah.
So we and the thing is most of them are metallic and platinum, which is my understanding. Is that true? Or
I mean, I like that as a thesis. We're
Yeah.
gonna go with it. I
Yeah.
think there's zero scientific evidence to back that up, but whatever.
consensus.
Let's keep going.
We're there.
This
All
room,
right.
you have the
Consensus.
consensus.
Yeah, it doesn't
Yeah.
have to be factual, it just has to be consensus.
Um,
Everyone raise their hands that thinks most asteroids are metallic.
So basically, when we look at the small body database from JPL, we get a lot of different things we can think of going to, and then we
I
narrow
totally got to do that
down.
action item that Matt gave me to add in the most recent Rubin data.
Yeah. I think we're working on that right now.
Good. Action closed, Matt. They're working on it.
Have you done it?
Well, it's not my job. It's
Action
it's
open.
Demian's job.
Oh, you see
Yeah.
that? Did you see
Yeah.
that delegation? Oh, actually, Demian's supposed to have that done. We don't know.
If you look at the ticket tracker, it's right there. Add in Rubin data. It's the ticket tracker you asked for, Robin.
Action done.
Action done. When Damien's on it, it's done, man. So
No, it just means I have an email waiting with a question from Damien. Can you get me the Rubin data import? All right,
All right,
sorry.
we're in small bodies database.
yeah, so we take all those basically small bodies and we look at through a high thrust trajectory which ones can we reach reasonably, and then
We
get
talk about a
like-
Holman transfer. Is this just doing like a basic Holman
This
transfer
is
to
doing,
see if you can make it?
essentially. We look at kind of so our firstly we're being dropped off by SpaceX in general. We're planning to be dropped off by SpaceX
I mean,
in a translunar orbit.
A launch provider. It's not
Yeah.
always SpaceX.
Sure,
We're launch provider agnostic on
because this is the
purpose.
previous one, is my understanding. Yeah,
For Odin, it was.
Yeah.
Yeah.
so that's the one we're designing to right now because it's the data that we have. Is
Yeah.
what we've received from that. So in general, someone drops us off. We then fly past the moon. And we get some change in inclination and some velocity from flying past the moon and using
Did
its
you actually get a
gravity.
gravity assist from flying past the moon?
You don't really always gain a lot of velocity, but you do get a major change in your like direction. And that is actually a major
Like inclination or phase?
Inclination is the main one, and you get to just shoot yourself up towards where the asteroid is.
Mhm.
And we're talking about like
Can
inclination.
you explain the
and
difference between inclination and phase?
I think phase can mean a few things in this case, but in general, inclination is like if you were to like say, flying around the equator is like one thing.
This is a
then
podcast. Your
off
arm
angle.
is
Yeah,
not
I'm
going to be
aware.
helpful.
I'm trying to like think for myself. What this
We
means.
have recording devices all over the place. We'll
but-
create a clip for this.
But
don't worry.
Rachel always tells us the battery died.
Oh, every time battery died, that one broke. She literally just broke one before this podcast.
On purpose.
My conspiracy theory is
During.
that she's actually just docking a bunch of like incriminating
Oh, yeah.
video of us, and she's just going to use it against us at some point. So
probably
I'm,
valid.
I'm on to you, Rachel.
So
Sorry, back to we're
yeah.
on the equator.
So,
flat elbow.
and then if you were to say fly around the poles instead, that's a 90-degree inclination change. So the difference
Got
between flying around the equator and flying around the poles is 90 degrees.
I get that, but we're not flying around the Earth. So explain this to me in terms of the universe.
When we look at flying, what we're talking about is flying around the sun, right? It's a heliocentric orbit. So whenever we are, if our velocity is aligned with where the Earth is flying around the sun, then we're going to end up in the same inclination as the Earth. But if we're able to go underneath the moon, and then that throws us up, essentially up relative to the Earth, then we're going to have a different inclination.
So inclination relative to the solar plane.
Yeah.
Okay.
It's the one that we care about because that's where the
He was never
asteroids
going to
are.
get that word, man. I know you were fishing
I was
for
fishing
it.
for it. I
I
was really
know.
trying, but I had to help
He's
you
trying
out.
to like use small language, and it's just not working for you.
What the hell is phase?
So that's kind of where we are relative to where the asteroid is in the orbit. So if the asteroid's on the other side of the sun, then that's a different phase from it being on the same side of the sun. So we're not really changing that as much through this burn.
Where do you think a random asteroid target for us is relative to the Earth, like when we launch?
So we're looking for stuff right now that is always within the same envelope as basically where the Earth is. That we have an envelope that is some range from the Earth and then some range from the sun. And so we're selecting stuff that is always.
Give me
within
some
that
damn
envelope.
numbers, James. I don't know what range means. How big? How big is that box?
That is 0.9 to 1.1 AU from the sun, and then within 20 million kilometers from the Earth.
Okay.
Far away.
At one point, what is 0.1 AU is what, 15,000
that's-
or 50 million kilometers?
That's the number I don't know exactly.
Yeah.
Wait,
It's
this is literally your job.
How do you not
Hey.
know the numbers? What is one
every
AU?
number. What's pi to 50 digits?
3.1419.
That's not your job.
872. Just keep making ChatGPT.
Yeah.
Chat bought it for like the first 3 digits, and he's like, "This guy's full of shit."
I got the 3.12, and I was like, I don't believe anything else past here.
I know it to 25, so I don't know what an AU is. Are you asking
Are you literally
ChatGPT
trying
to
ask
talk into the mic?
ChatGPT to talk into. Okay.
Hold on, can we replace James with ChatGPT? Is that what you're telling me right now? Are you GPT 5 or 6?
Probably 3.5.
Okay, that's fair.
Yeah.
All right, so basically
Grok.
you're trying to measure between Earth and Sun, and you said roughly 20 million kilometers in either direction relative to the spacecraft.
Yeah, and then we're also looking at basically ones that are what that does is it limits the relative velocity
Okay.
of the asteroid to the Earth. So if you think about, say, an asteroid that's just not near the Earth for very long, that means its relative velocity is large. And so we would have to carry a lot more fuel to be able to
Propellant.
ever catch up to it. Propellant, yeah. To ever catch up to it. So if it stays within that envelope for a long time, then that means its relative velocity to us.
Hold on,
is
can we
small.
hash this out? Why do you not want to call it fuel? It's fuel for the engine. Why does it have to be propellant? What is the difference?
This is the wrong episode to talk about that.
Well, we don't have a propulsion team to have an episode with. So.
Once again, you can look at my LinkedIn profile.
If we call it fuel, then it saves on our total data storage. It's fewer characters.
No, it's just a pointer anyway. Literally doesn't matter how long the name of the variable is.
In Notion, it does.
Oh man.
All right. I don't even remember how we got here.
Welcome to Roid Rage. Welcome
Aren't you supposed to be the moderator?
Yeah, but I've been moderating for an hour and a half at this point. I think this actually might be my limit.
So
we're
the
gonna have to
next
walk
step
through it. Yeah.
for asteroid so we select an asteroid or a series of asteroids,
Yep.
and what we get from that is basically a threshold for how much delta V we're going to need or how much propellant we're going to need to be able to reach it. And so anything above that threshold we can throw out, and
Okay.
the other ones we will look at essentially with a telescope to determine which ones have the most basically rare earth minerals, platinum, et cetera, on them. So we don't have to look at everything and characterize all 40,000 asteroids. We look at like 10.
Yeah.
And that saves money and time.
We had Al on this podcast a while back, and he explained all that to us. It was actually
Okay.
pretty cool.
Yeah.
How much propellant do we have on the vehicle?
Around 6 kilometers per second of propellant. I think it's around 60 kilograms.
Okay.
Which is out of a 200 kilogram vehicle, enough to get us those 6 kilometers per second. Where in general, over the course of a day, we can do 25 meters per second of.
That's
delta
actually,
V.
yeah. I think when we talk about low thrust, I think that's the number we should be talking about, like 25 meters per second per day.
Yeah, not much.
Yeah. Versus like, when you use bipropellant, you're going to get a kilometer, well, maybe not a kilometer, half a kilometer per second delta V in a matter of minutes, maybe hours.
And the key to that then is that what we end up doing is looking at essentially whenever we look at control theory and optimizing those burns, what we look at is the first thing we look at is a bang bang trajectory is what it's called. And that just means at the start, you do full thrust, and at the end, you do full thrust, and in the middle, you do a lot of coasting. And that may not necessarily be optimal because there might be multiple flybys you can do and target that you will want to burn for in the middle of your trajectory. But we're still just going to be doing the same thing ultimately, where we do a lot of burning at the start and a lot of burning at the end, and then a lot of coasting in the middle, where we just try to use all that fuel. And the earlier you use it, the more efficient you get.
Yeah. I think I'm just going to take this over, man,
Go
because
for it.
you're like faded over there.
Yep. Happy to hand over the reins here.
Yeah. So, one of the conversations we had recently was talking not just about the orbital mechanics part of the orbital mechanics, but sort of the operational options part of the orbital mechanics, right? So the most optimum trajectory mathematically, if it's on like a knife edge of a solution, if you don't make it and you miss it, you could be off the cliff and not be able to make your mission versus some less optimal trajectories that have a much shallower gradient on the solution that you'll have options if you're off by a little bit to get back on track.
And the way you can think of this is if you are on the highway and if you're aiming for the last possible exit before you go across a bridge and you miss that exit, then you've got to come all the way back around.
That's good, yeah. I had a hiking analogy, but that one's better. Cool.
Yeah.
I mean, I guess it is your job. So
Come up with analogies, yeah.
yeah, you don't get brownie points.
How much of a difference in you talk about these like optimized first order trajectories, how much of a percentage difference is there between the results you get from them and what we think we'll get in continuous thrust?
So we're not seeing a huge difference if the trajectory is fairly simple. So the more burn periods you have,
Hey,
the
hint,
less
we want a
optimal you
simple
get.
trajectory.
Yeah.
Okay.
We
Well,
kind of
yeah,
have to have a simpler
operationally simple.
trajectory. I mean, there's no
No.
flyby planets within
No,
15
but we
million
can-
Close to the
kilometers.
Earth.
I mean,
What
yeah,
makes
there's
a
the Earth
simple-
and
what
Moon. We
makes
can
a
totally
simple
loop around them.
trajectory?
That, like I said, originally the bang bang solution where you do one large burn at the start and one large burn at the end. Of course, this burn the reason why we care about making it simple is it's already going to be complex
Yep.
because a large burn is complex naturally.
Got it.
So if we look at like a plot of the actual thrust we get over the course of 5 days of firing these thrusters, it's not a straight line. There's a lot of variability in it. And so we don't end up where we expect that we're going to end up all the time.
What? Oh no!
How much variability is there? Like,
Maybe
give me
Rachel
some
can
units
put
of
put
quantifying.
one of the plots of this
I
on
would
our
say
podcast.
Around we're looking at around a percentage point or so, maybe 2%.
So does that mean if I go
actually
15,000
quite a bit.
kilometers away, I could be off by 150,000 kilometers?
That's another study we're going to have to do soon. Is how much are we going to be off relative to what
Action
we
item.
expect? Yeah.
Sounds like a lot of missed distance.
It can be a lot of missed distance. So that's why we have to stop burning every once in a while and look back at the Earth and say, hey, I'm over here. And then we're going to stare up and say, all right, so we have metrics on the spacecraft of like how much power was actually delivered. Did we fire for the entire time? And then also when we look up, we have a search pattern to go and find this spacecraft because it may not be exactly where we think it's going to be.
Why is it so hard to navigate in space?
Mainly because we don't have a lot of road signs and GPS and stuff like that. So it's a lot of
GPS global positioning.
We're looking at a lunar positioning system soon too, but we're still not on the
Weehoo.
moon. I think like the world in general. It's a multi
Yeah,
agency
that works always great. So the UN's in charge. What is fucking NATO going to roll on some?
No,
lunar
don't worry. The
GPS?
ITU controls everything.
Okay, ITU, whatever. Yeah.
I don't think the UN does anything, so I think it's ESA and NASA
Masonic
currently.
Lodge.
Maybe some
NASA's fully
JAXA.
funded. So
What do
okay,
you-
Yeah, they're doing great. I heard.
So all this math you're talking about, what tool do you use? Don't tell me calculus, man.
So the
looking
first
for code.
order is we have some PhDs who use a lot of intuition to come up with like the first guess. And so this is
Great.
just kind of
We guess. That's our answer. Oh
It's
man.
the first guess. So there's you just distribute a number of guesses out and you get.
I
the
feel
right
like
answer.
I need to pull out the poster of like Go Upper 5.
what?
Have you not seen the Go Upper 5 poster?
No.
It's the kindergarten, like it's the 100
it's 100 words, right? Like
it's the
most
100
popular
words most used
Yeah.
or most known in the United States
English language
Okay.
in the English language. Yeah.
to describe the Saturn V.
And it's literally a technical poster of the Saturn V, and it says like the title of it is Go Upper 5.
It's actually really helpful.
This sounds pretty cool. Yeah.
Yeah, it
this
would,
is-
but like you guessing at where our deep spacecraft going is making me
Sounds like
want to
that.
have like a design review right now. Like, don't make me CDR you.
well, we know how to change an inclination of an orbit, but we have-
ChatGPT Go Upper 5 and it just put a picture of Sam Altman. They're confused.
Okay,
All right. Okay, cool.
some room for improvement there.
Yeah.
All right, so after you're done guessing, please tell me you do some math.
well, we tell it where essentially we think it's going to have to do burns, and then we actually use some tools
What is it?
developed by NASA.
Mhm.
So we tell a tool
a
developed
tool?
by NASA
Okay.
where we expect it to want to do burns, and then it will move those around for us automatically as we try to minimize the total amount of fuel that we use or propellant that we use on this orbit. And then we do that consecutively until we get an orbit that is fairly optimal, like pretty close to the optimal solution that we were expecting. And this will sometimes spit out results that we don't expect, where, as an example, we
Because you
had
guessed.
Well, so I didn't guess. This is someone else who guessed. Won't name names. We had a nominal trajectory.
Have
for
you not
Odin.
listened to Roid Rage? That's all
Yeah,
we do is
you
name names.
Absolutely name names.
So Sam Altman. I mean, we didn't ask GPT. No, this is the Odin trajectory nominally was,
Gotcha.
and what we built the asteroid database off of.
That's not a bad
was-
guess.
It was a good guess in the
Yeah.
sense that it was a very simple mission where we did we just did a Lambert or a Hohmann
Real
transfer.
simple. I just went straight for about 2 weeks and then we stopped talking to it.
We're waiting for it to come back and hit Vestry on the return.
It got its gravity.
Launch Vestry.
It got a gravity. Oh, that would suck. That sounds like hitting your own car in your driveway. Like
That sounds like my wife.
having your insurance company on two different lines. Like I just got hit. I just hit someone.
I mean, my wife did have a car accident with my house.
You want to talk about that?
Yeah. This definitely sounds like a trajectory problem. Okay, let's make sure we don't hit Odin with Vestry. I know the chances are really, really low, but like, no,
It's a good
really.
thing to keep you up.
Yeah, great. We fill out the risk ticket.
So in general, that one, we actually found a trajectory that, I don't know if it was the exact same asteroid, but for an asteroid that we'd already computed and estimated delta V to, we found a much lower delta V while going through the low thrust
Like
solution.
what's how much lower? Like as a percentage or as
3
meters?
times lower. So like from 3 kilometers per second to 1 kilometer per second, sort of lower.
Wow.
And this was
That's a
by
big
doing
deal.
a flyby of the Earth.
I mean,
after
that's
the flyby
tens
the
of
moon.
kilograms worth of propellant.
It's enough that we could fit a full pickaxe onto the spacecraft to do the mining.
Oh my God. We have our first Minecraft reference that I'm aware of on this podcast.
I didn't reference, you referenced Minecraft. I referenced pickaxe.
Everybody knows what you're talking about.
Okay.
We're not. Don't gaslight me.
He tried, and he failed.
Doesn't work on Robin.
No.
Also,
not
why
yet.
don't we call the next vehicle Minecraft?
Why aren't we trying to sell the rights to Minecraft?
Because that Microsoft owns it.
Why don't we
Doesn't
get
mean we can't sell
Microsoft
it.
as an investor?
Yeah.
Because I'm not that good.
All right. Well, at least we got the answer
Well.
we're looking for.
Back to Pip.
Yeah.
So basically, we were able to, we could have done the same trajectory with a high thrust, but we didn't use the optimizers that we had for that high thrust.
Oh, so we just didn't do our job well enough last time either.
It wasn't necessary in that case because we didn't have as complicated of
Yeah.
of a con ops essentially.
Gotcha.
Yeah.
Okay.
But in general, the methods are we take an initial assumption or guess, or we can actually generate that out of nowhere if we use the right tool, and then. But typically, we expect that our initial guess, our assumptions of how to make an orbit, are superior to what you just randomly get out of a tool, and they're much faster to set up. And then we actually have the orbit get optimized through this tool, and then we'll continue to do that until we get a number we like. That's basically it stops decreasing. So it's a form of learning that's old fashioned. Like machine learning, they keep optimizing.
Are you about to orbit splain
Yeah.
like old school to me? Like
Yeah.
don't make me get out a slide rule.
Like it's a Heinlein book. We pull out the slide rule on Jupiter or whatever, on
Yeah.
the moon of Jupiter,
Yeah,
and
yeah.
do some math real quick.
Chap, save us.
You took over. Don't hand this back to me.
Well, you have the sheet.
Like the sheet matters at this point.
No, definitely sheet doesn't matter.
All right, so let me just get it back on track. You've done orbits before. What is unique about planning an orbit for a spacecraft like Vestry to things that you've done in the past or industry in general?
Yeah, so Vestry, firstly, most of the industry does just orbit maintenance. So they have maybe some low thrust or something like that on board, and they just try to stay in the same orbit they're always in.
Got it.
Boring.
Yeah, it's
Can you compare
pretty
us to like some
typical.
cool shit, like what NASA does? Like compare us to Psyche. How are we doing it different than them?
So Psyche in general has
What
honestly we're
about
doing it
ESA?
very
I mean,
similar to
Rosetta
them.
was pretty freaking cool.
Compare us to any mission that's not just orbit maintaining.
Yeah, that was the next step. Is Psyche is we're doing a lot of stuff similar to what they were doing because we're trying to target this asteroid out in the middle of nowhere with a low thrust system. We are not going as far, and we don't have the same amount of like just
Money.
Yeah, fancy support, billions of dollars. We're orders of magnitude less.
Once
expensive.
again, putting out the call. If you have an instrument left over from Psyche that you wish had been on Psyche, but you'd like to go to a metallic asteroid, just saying,
we'll take it.
we're here.
You can give Robin a call at.
Reference the other episode.
5, 6. I mean, yeah. So the main thing that we do differently is that we are developing this for a variety of asteroids. So we're developing a pipeline because Psyche had chosen
Pipeline.
a asteroid called Psyche initially, right? And
It was
we
very
were
confusing. They
choosing-
named their mission in the asteroid.
Yeah, we didn't name Odin 2022 OB5. You know, that would be a terrible
Yeah, but it
name.
also wasn't named Psyche.
Yeah,
Maybe if we
fair.
were going to Psyche, we'd have been like, yeah, we're Psyche.
I mean, honestly, it's probably the most like probably the best name. Like you don't ever have a question of where Psyche's going because it's going to Psyche.
It's going to itself.
Yeah, think about that. I mean,
It's just a pointer.
they didn't name
just a
Cassini
pointer.
Saturn or Juno. I guess Juno.
They were trying to save space. They make the name the same as the asteroid, and then you could just be
Yeah,
like,
you
we
just
don't
point to the same
yeah.
thing. You're right. Thank you, chap.
Hey, say more about the this thing. What is a pipeline?
Yeah.
So the nod, it's so cute, y'all. Yeah, we
It's the bald nod.
the ball. Yeah, you can't even tell that it nodded because
See, we
the
don't-
same
I-
sheen across.
Yeah,
as you move your
yeah.
head.
It's
Yeah.
it's the reflection. Yeah.
Optical illusion.
Yeah.
It never happened.
The pipeline that we have is we take a series of asteroids and we take a series of initial guesses for what our initial trajectory is. So
What's the format of this?
Um,
Come on, let's get technical.
so the format is that we receive a bunch of spice files.
Spice files.
JPL. We generate a bunch of spice files actually, which are JPL format for how we define an orbit.
Okay, so JPL's got this standard format that everybody uses because it's JPL and they're the ones that
They've
have
been
been
doing
going
since
deep
the
space.
70s
Yeah,
with Fortran, so we trust it. Something. And then we
that was my original. I literally programmed in That was a degree requirement to program in Fortran.
Wow.
Fortran 77.
I think that's the best Fortran.
is this before computers?
It wasn't. I didn't use punch cards.
Okay.
No, Fortran's a legit language.
Yeah, no, totally.
It's a
I mean,
real
we
language.
still use it today. It's what actually libblast is based off that I guarantee you use. So
Yeah.
you
Lots
use the
of pop-
Fortran 77.
You know what's really miserable about Fortran is that the Intel compiler is not the same as the Open compiler.
I mean, that's for all compilers are different for different chips. That's
I-
the point, right?
Well, no, whatever.
It was a pain when we were compiling. We were compiling
doesn't
some
compile.
optimization.
Yeah, it doesn't
libraries.
compile. It's a total
Yeah.
pain in the ass.
Yeah, we had to download new.
Okay,
new compilers.
thanks. Appreciate
I
you
know. I
supporting.
got you, Robin. Total backup there.
Yeah,
Damn.
Robin's on his own out here.
Yeah.
He's like Odin.
Wow.
I wasn't here for Odin, so I can not say that. I guess actually.
Yeah,
Sorry
so
about that.
Shut up, James. Okay, so back on track for the 50th
save
time.
us, Matt.
For
Look, we have this
pipeline.
pipeline. We got spice file. What is in a spice file? I hear this word all the time. Like, what's a spice file? What's contained in
So
it?
a spice file is an interpolation of a bunch of points. So it basically contains the ability to reconstruct a trajectory.
So is it just a bunch of points in what coordinate frame? Universe frame?
Yeah, essentially, universe frame is the good way to put it. ICRF is the other way.
Which
that
stands
we-
for what?
International Celestial Reference Frame.
Okay, so
You can also
universe
just
frame.
say J2000, which I have
Yeah,
no
so
idea
that's
what
not
that stands
universe
for.
frame. That's like solar system.
Solar
frame.
system
Yeah.
frame.
Yeah.
Which is the
I
universe
should
I,
say
care
solar
about.
system.
Yeah.
I'm using universe to
I
mean
know,
solar
I
system, and I'm
know.
being wrong. I know.
Yeah.
Okay.
It's not even.
Solar
It's
system
not even
frame.
The
galactic.
Galileo frame, yeah.
Yeah.
Okay, so we have solar system frame of all these points, and we got all this data. Cool. What do we do? That just tells us a trajectory of where the asteroid is.
So this tells us a trajectory of, so we have spice files for everything. So this tells us the trajectory for our initial orbit that we're expecting. This tells us
Initial
the-
orbit for the vehicle leaving the rocket.
leaving the rocket.
Okay.
Yeah. So we basically don't know exactly what that initial orbit's going to look like, so we do a lot of them. And then we have a trajectory for each asteroid that is produced by JPL in a different spice file. And then we split this trajectory that we're doing into 3 segments. One is approaching the moon, one is the actual flyby, and one is post-lunar, We just try and reach the asteroid, and that's where we have the bang bang trajectory 2 burns. So we don't know if we're going to have a chance to burn before the moon. We have around 3 days, sometimes more, sometimes less, depending on the launch provider and the mission that we're ride sharing with. And 3 days isn't a lot of time to calibrate your engine, basically. And it's also the case that if we do it wrong, then we may just hit the moon, or we'll just not
Don't
know
hit the
where we
moon.
are.
I have very few.
So the moon is an asteroid. I don't know what the problem is with hitting the. We've done the mission.
It's not interesting.
Not okay.
It's actually really fucking boring. Yeah, it's definitely not an M-type asteroid.
It's not an.
I don't
M-type
actually know if it's
asteroid.
definition asteroid, but it's not M-type. So, okay, so we do this. We have the 3 burn segments. We use these spice files to tell us where we are and essentially tell us where we're going.
Yeah.
And this pipeline is what? Are we taking where we launched from with putting some noise on it and doing this calculation for every single asteroid in our database, which is 100,000 plus?
So we're doing it based upon a priority queue. So we take the most important ones and do them first.
Important ranked as what?
Ranked as easy to reach combined with being metallic.
Okay.
And so we select the ones that are metallic and easy to reach first, and we do trajectories for those, and we come up with which ones make sense for the time that we launch and the.
How long does one of these trajectories take to run or to calculate?
Depends on the pipeline. So we're working on different ones right now, but the current one that we have is around 6 hours
per trajectory. So if we want to go to all
trajectory.
100,000, that would be 600,000 hours.
Yeah.
Which in Google Cloud time is pretty cheap. So
around $20.
okay, so
That's not true.
that's absolutely not true.
No,
Not by the
that's
last
absolutely
budget
not
we
true.
got.
No, let's not. Yeah.
I was told we could take the limit off BigQuery and just run some more stuff.
So what happens when you make a more?
That's also
You
not.
said that there's a pipeline optimization you're doing. What are you actually doing to make it cost less?
So we want to choose
Using
tools
Fortran.
which are flight proven. So we have currently the pipeline we uses EMTG, which is not a flight proven tool. It's nice
What's
because
ENTG?
it was built for EMTG, was built
EMTG.
for other asteroid missions.
Hmm.
So in that sense, it's really convenient.
Built by who?
It was built by NASA. I think I don't recall which center. One of the centers.
So, but not JPL.
Not JPL. I don't think it was Goddard either.
So
Not
it's
even
like
Goddard.
competing NASA center code.
So
There's a lot of
the
competing
evolutionary
NASA code.
mission trajectory generator, and it's built by JPL.
Oh,
Wait, hold on.
no.
A software tool developed by NASA Goddard Space Flight Center
Goddard's
we
pretty
go.
smart.
with the title of JPL. So I don't
What?
actually know what ChatGPT is telling me, but one of those. So that
Sounds like
I'm
Matt's
sorry,
hallucinating.
we say that this has never been flown to space, but Goddard uses it. So
Goddard built it,
Uh-huh.
but they actually use GMAT, which is a different tool built by
Yeah, but I don't
Goddard.
understand. Can't we just run this against previous missions and determine if it's correct or not?
There haven't been previous missions for low thrust to asteroids that I'm familiar with.
I thought there was one that starts with a P and ends with a Ike.
Psyche.
Has it reached it?
I mean, it's halfway there. Like, its
Ah.
position now.
They haven't told us exactly what their burns were, as far as I know. But in
Give me the
Problem
name.
is we need the actual data of what
It
their
has to be
burns
flight
were.
proven in the sense that it's been a successful
Oh,
mission.
Okay.
And what that would tell us is that
So instead of asking for the leftover instruments from Psyche, I should be asking for the actual flight data.
if they would just give us Monty and their flight data and all of their tools, we would gladly take those. Yeah. Anyone who wants to sneak away from, right,
Well, I mean, it's technically it's U.S. taxpayer owned, right? So that could be like a FOIA request.
I keep saying we should drop a USB in the parking lot and then see if
No,
one of
you
them
should
picks
not
it up.
drop a
Oh.
USB in any parking lot.
No.
We're gonna edit that out.
I
No,
think
we're
we
not.
only have like 10 listeners.
Yeah. Okay. Fair enough. Well, no need to edit it out. All right. Yeah. So pipeline, you got to validate it with real flight data.
Yeah.
Since you don't have
Or
it,
flight-proven tools.
you're
yeah.
you're using flight proven tools because they got there and you're like, cool, you found the asteroid or the comet or the planet.
essentially.
Cool.
Kind of discussed all the stuff that I thought was most relevant to trajectory and
I
design
mean,
for
summing
this.
it up, right? So basically, you guess, and then
Yeah.
you use computer code that you didn't write, and you compare it against other computer code that you believe is right, and then
we launch a really expensive
And then we launch a
spacecraft.
really expensive spacecraft on 3 segments, and I pay for Google Cloud time. Yeah, I think that about sums it up.
Yep.
Mhm.
I don't see a problem with this.
Yeah. Okay.
Hmm.
Cool. Orbits. And there's some math in there. Every once in a while, maybe calculus.
We do some math. We do some pipeline stuff. We talk to it at some
Yeah.
point. We determine where it is at some point.
But intuition too. Intuition and math.
Yeah.
Yeah.
Well, so long as we're close enough to the asteroid, it's all Armand's job anyway.
Yeah. Prox ops.
Yeah. Just got to be directionally correct.
Yeah.
Okay. Cool. Awesome. Well, with that, let's roll into mailbag. James, you may not be aware of this, but we also let our internal guests ask a question of Matt and Robin. So think of a question that you want to ask of either of them while I ask the mailbag questions first.
And he gives them time to think about it.
Yeah. Just
It's because I called him I pretty much said he was the Buster Douglas of moderators.
Who's Buster Douglas?
The guy who beat Tyson once and thought he was good.
Oh,
That's it.
that actually might be the oldest reference you've made. Like, I don't think you can give him shit for old references anymore. Like, no. Race, do you
well,
have any
Buster.
idea? Yeah.
Buster wasn't. It wasn't in the Mike Tyson video game on Super Mario Brothers.
No, that's
Punch
'cause
Out.
Mike Tyson at that point, I think, was still undefeated.
Yeah.
When did Buster Douglas knock him out? Like 19? I think it was 1990.
That was 9.
I saw the fight where he bit George the
I
ear.
thought Mike Tyson was just from the video game.
Holyfield.
Is he real?
Is that a real question?
That's the question for the now.
All right, we're gonna go to mailbag. Anthony from Substack says, "What happens?"
We have a Substack?
Yes, we do.
Amazing.
What happens if the battery is full and you need
What's
to shunt
Substack?
power?
A Substack is another blog? Who writes for the Substack blog?
I'm posting our articles.
Oh, you just put our articles on
Yeah,
Substack.
Yeah.
Do we
What's-
charge people?
What's Substack?
No one's paying right
Think
now.
of modern day WordPress.
What's WordPress? That's what Robin's follow-up question is.
Okay.
What was the question?
Robin, it's Facebook for blogs.
Oh,
Yeah. Okay.
Gotcha.
It's like
An-
MySpace.
Anthony from Substack. What happens if the battery is full and you need to shunt power?
We shunt power by using heat. I mean, you turn electrical power into heat via some kind of resistive element. So that's essentially what we do. It would be dispersed as heat on the spacecraft.
Okay. Anything to add there?
nope.
Okay. The next one is from Ford Rundell. This is a long series of questions, and I'm going to sum it up into one easy one for you to answer. But it starts off with longtime listener, first time emailer. Could you do a full episode on your extraction and refining process? Deep space is okay, but rocks and mineral processing are way cooler, in his opinion.
Sounds like we need to have Chap as a guest.
Yeah, maybe in the future we'll have Chap as a guest, and he could go all through rocks and minerals and shit that I don't actually care about.
All the names, like the waspaloy. No.
Yeah, they have like the worst
waspanite.
names, right? And they call. I
There's
mean,
a lot of odd ides and alphites. And,
Yeah.
Yeah.
People come into, like-
Waspacrystallinite.
Yeah.
sulfites. I still don't know what that word means.
Crypto
Yeah.
chain.
We don't do that kind of
Wasta.
If you think we're doing that kind of
Oh,
mining on
look,
the
I hit a
asteroid,
sore spot. I hit a sore
We're
spot.
definitely not doing that mining on the asteroid. So the short answer is we'll do another episode later at some point to talk about mining. Is that the answer?
Yes.
Okay, cool.
We could just make this a double header
Also, Buster
episode.
Douglas lost in February 11th, 1990.
Okay,
That was
yeah.
pretty. I'm
Yeah.
surprised I knew that.
James, question
Yeah.
for either or both of the esteemed gentlemen sitting to my left and right.
Yeah, I'll ask. I'd like to ask Matt actually. So you've grilled me a few times on filter work. I know you've done filter work in the past. What was that work that you did?
The only filter work he's done is change his oil filter.
Oh, I don't even do that anymore. I go to that drive-through Valvoline oil change. It's amazing.
They're fast.
Yeah, I tried to actually change my
Yeah,
air filter.
because they don't
on my-
bother to put your oil filter back in.
And every time they take out my air filter and show it to me, like I'm going to buy a new one. I'm like, no, just stop fucking with my car. Look, we've all previous career when I started at Virgin, that was my job number one, was figure out at Virgin Galactic, which became Virgin Orbit, was write the first navigation filter for what became Launcher One. So there's been a whole bunch of experience.
How'd that work out?
I mean, it knew where it was going.
The important
It didn't
part.
make it there because of the propulsion system. But that's a different story. Pretty sure that the propulsion filter. What happened on mission 1? Actually, was it
They took it to Valvoline.
right? What happened on mission 1?
It broke.
Well, it was a filter in one of the fuel lines, right?
No,
No.
no,
Okay.
that was a different mission.
Was it? Oh, did it just literally broke?
Yeah.
Gotcha. I remember reading that the stresses were just, was it on the gimbal or?
Dude, plowing through the atmosphere sideways transonically is just a bad idea.
I mean, that is true. When you drop a rocket off the wing of a 747 and try to then make
I mean,
it go to space,
first you got to
like,
carry it on the wing of a 747. Have you ever stood next to a jet engine? It's really loud.
yeah.
So like acoustic energy, like your rocket is
But I
absorbing
will say,
all
when
that
I went
for
out there and saw,
hours.
so it was 747. When I went out there and looked at it, it looked like you were in a video game and it was like select your weapons for your aircraft. And
Oh,
you're
it
like,
totally
what's
did.
the biggest fucking one I can put on there, right? And it's like you can only carry one of these because it's too big. Like that was the jet, and it was pretty badass looking.
Yeah, it actually was.
The engineering on that was so fucking fun.
Yeah,
and
it was
so
amazing.
cool, and the business model
It's
was
very
so
cool.
fucking stupid, but it was a lot of fun. But that's where a lot of my experience comes from before, was working at Virgin Galactic and some stuff before that. But I think the main one was that filter.
It's awesome. It's a sick job.
I mean, let's be clear what a filter that you're talking about is, because we've mixed a lot
We're
of metaphors.
talking about something that we would probably refer to more as sensor fusion at this point, which is how do you combine data from an IMU, data from GPS, and other sources of data coming into it to determine your position and attitude of any kind of given vehicle.
There you go. Just want to keep it technical.
Yep.
Anything for Robin?
Nah, I don't have any questions for Robin.
All right.
Wise man.
Robin gets off easy. That's a wrap for this episode. James, thank you very much for talking about orbits with us and how we calculate them. Tune in next week for, I don't know. Yeah, I'm done. Tune in next week. This is a wrap. Thanks.